Welcome back to the first lesson in week 16. In this lesson, I'll introduce a computer simulator called the Little Man Computer. In this lesson, I'll explain what the Little Man Computer is and what it is used for. We'll look at its instruction set and I'll introduce some of the activities we'll be doing this week. So the Little Man Computer is a simulator of what goes on inside the processor when the computer runs a program. It was invented in 1965 to introduce university students to how computers work. As the little man runs about inside a room, he's doing the actions of a processor as it carries out the instructions in a program. Obviously, in 1965 it was done entirely on paper, but nowadays we can also find websites that will run Little Man computer simulators. There are several items in the room with the little man and he can run around between these items. The different items stand for the different parts of the computer processor. I expect you can imagine what they all are, but let's quickly go through them. The little man's got a calculator. In the original ones it was an abacus because calculators hadn't been invented. He's got a calculator anyway that will do sums. He's got an inbox and an outbox. He's got 100 numbered storage locations. In America they call them mailboxes. In England we'd probably say pigeonholes, but let's just say they're storage locations. And he's got a counter that counts through the instructions as he carries them out. So they obviously all represent well-known parts of the processor. The calculator is like the ALU. The inbox and outbox are like the inputs and outputs to the processor. The numbered storage locations are RAM, and the program counter is represented by the counter. You should know what all those different parts of the processor do. In addition to these different items, the little man can understand a set of instructions, and these instructions are the little man's instruction set. That should be a phrase that you're used to hearing. We've talked about it before. The instruction set of a processor is the set of instructions that that processor can understand. Different processors have different instruction sets. For example, some have a complex instruction set and some have a reduced instruction set. In any case, the instruction set is hardwired into the processor in the factory. A computer program consists of a series of binary numbers that stand for different actions or instructions, and these binary numbers are decoded by the processor during the fetch execute cycle. These instructions can be represented in two different ways. The computer understands numbers, so we call that the machine code. That's the set of numbers that represent the different instructions. We also have a way of representing the same set of instructions using simple words, and that's invented to make it easier for human beings to understand the instruction set. And we call that assembly language. So the Little Man computer has got 10 instructions that it understands, plus some memory locations just store data on their own without any instructions. So these 10 instructions are called the Little Man computer instruction set. I'm not going to go through all of these now. If you're my student, I've given you this as a handout. And you do need to eventually memorize all these instructions. The word version will do, the one that uses short words. For example, if we look at the first of these instructions, if the computer, the Little Man computer, reads the instruction 1, he knows he's got to add a number to the accumulator. Or we might write it with the word add, A-D-D. You'll see that in both cases I've followed that instruction code with a little XX. We wouldn't really write XX, we'd write a numbered memory location, and the computer will go to that numbered memory location and find the number that's there and add it to the accumulator. I'll go through in full the different actions that the computer can do, and we'll be trying all of these as we run our simulations. A program is a series of instruction codes. When we run a program, we point the program counter to the first instruction in the program. Let's call that storage location 0. It depends where the program is stored. The computer will fetch and execute the instruction at that storage location. The program counter will increment count on 1 to the next storage location, and it will keep fetching and executing instructions and incrementing to the next instruction until it reaches the instruction halt, which stops the program. So I will give you some simplified programs written using the LMC instruction code. We'll run them on paper using a trace table to see what's going on inside the program. We'll then run programs using web simulators, and if you get on well with this, you'll end up by writing your own programs using the Little Man Computer instruction set. There are a range of online simulators that we can use. I've put links to all of these on our VLE if you're my students. If you're not my student, you can easily find these by typing LMC simulator into a search engine. So to recap, LMC means Little Man Computer, and it's a simulation of what goes on inside the processor during the fetch execute cycle. The Little Man understands 10 instructions, and I've given you the codes for that, and we can run simulations of the Little Man using paper or online simulators. So let me leave you with an exercise to show understanding. What I've written on this screen represents 6 storage locations, then they're numbered from 00 to 06, so 6 storage locations, and each storage location is holding a number code. Some of those represent instructions, some of them represent data. So copy this into your book. So the first numbers, the ones that are not in bold, those just represent the numbered storage locations. The bold numbers that follow are what is stored in that storage location, Little Man instruction codes. So copy that down, and then next to each one write the assembly language equivalent of each one of those instructions. I'll go through this next lesson and we'll run this simple program and see what it does. So I'll see you in lesson 16.2. Bye for now.